Hi guys, so today we're going to be discussing Leetcode question 206, reverse the linked list. So the question is given the head of a singly linked list, reverse the list and return the reverse list. So we had discussed an approach regarding this, how to do this, but using an iterative approach, which was involving a loop to loop over the linked list and reverse it in place. So we discussed an iterative approach for that, and the algorithm for this was essentially this. You can check the video for that. I'll leave the link for that in the description below. I just wanted to take some time and discuss how can we come up with a recursive code for this approach, using the idea from what we discussed in the iterative approach. So people have a lot of trouble coming up with recursive solutions. I just wanted this video to help people like how you can come up with a recursive idea. Once you have come up with an iterative approach for the solution, you can easily come up with a recursive idea. How? Just like in this example, we came up with the iterative solution where the main part of the algorithm was this, where we save the next node of next n using this code, reverse the link using this code, and then shift to the shift current and next node to the next node using this code. So this is essentially what would be our main part in the reverse recursive code as well, and we'll need to add some base cases which will almost be similar to this. So let's see how we can go about it. So I'll first write the algorithm. This was for iterative approach. Iterative. Now we're going to discuss a recursive approach. So the algorithm for that is, the initialization part is the same. We initialize a current which will start from the head pointer, and we have a next n set to the current dot next. We put the next of current linked list to null because when we reverse the linked list, this would be null. And then in a different utility function, basically a separate function, we compute this return. We basically define return, let's say a reverse. This is a different function, utility function, in which we pass current, the next node, and also the next n next. So this is essentially next nn, the next of next node. Again, why are we using this third pointer? If you remember from the previous video, we use this pointer to keep track of the linked nodes ahead once we reverse the current linked list, because once we reverse the current link, we won't have any way to traverse to the next linked list node. So that is why we need to keep that information stored in this third pointer. So that is why we use this. Once we have done it, we write a base. We first need to define a stopping condition, because we are using recursion, so it needs to have a stopping condition, otherwise it would go into recursion for an infinite number of times. So I'll come to that later. I'll just leave this for now so that we know we have to come back to this later. So essentially the main part of the algorithm would remain the same. We first set the next of next linked node, which is next n dot next. We store that information, then we reverse the link, which is using this code, next n is equals to current. So this was, I'll write it in a different color, store info of nodes ahead. This is reverse current link, and then once we have reversed the current link, we just move to the next nodes to reverse their links. So basically we move the current to the next node, and we move the next node to its next node, which is this. So if you notice, this part is essentially the same as this part here. So we just have copy pasted this code from here to here, as this is our main idea for coming up with the recursive solution, for the main idea for iterative solution or recursive solution. Now once we have done this, so this is essentially our algorithm, but we need to define a stopping condition, which in this case would be if next n equals to null. Basically we reach a point whose link we do not want to reverse. This is the pointer that will store the node's information whose link we have to reverse. So if we reach such a point, that means we're all done. Just return the current linked list, return the current pointer. So this is the stopping condition. Let's understand this via dry run of the example. So let's say this is the algorithm that we have, right? So by the way, yes, we have missed one thing. So once we have done this, we need to add recursion in the end. So we just return the recursive function, reverse the same function what we used here, reverse utility function with its new updated parameters, current, next n and next nn. So this is essentially our code for recursive approach. So let's understand this via dry run. So let us assume this is the example that we have. We'll use the same example, 3, 4, 5, and this is the head. I'm just writing abbreviations. So initialization part says this would be our current. So this is done. Next n is equals to current next. So basically this would be next n. So this would be, my apologies, so this would be nn, and we set this part to null. So basically this link is removed and we put this to null. Basically in the reverse linked list, the head of the current node, the head of the current linked list would be the tail of the reverse linked list, right? So that is why we do this. And then we execute our recursion function in which we pass these 3 parameters. This is essentially next node nn. So basically next nn, the next of this node. So how does this work? So this line is executed, we saved it here. We reverse the linked list. So essentially what we do is the next of next n, we put that to cur. So basically now the next of this is moved to this and this link is removed. Sorry. Once we have done this, so this you can see is essentially a reverse linked list now. So once we have reversed the linked list, we move our current pointers to their next positions, which is this now becomes current, this now becomes next node, and this is the third pointer that will update in the next recursive call. So now we go into the recursion again. So this line is again executed, next of next n is equals to next n. So this is set, the information for the further nodes are set. So now we reverse this link using this line over here. This link is broken. Once we have reversed the linked list, we move the current pointers, which is current and next node, to their successive nodes. So this moves here, current moves to next node's position and next node moves to next of next node's position. So this is what next nn becomes. Again we go into the recursive call, which is here. This condition is not yet matched, so we execute this function, this line next nn, we set next nn to the next of next node. So this becomes next of next node. We reverse the current linked list, which is next n dot next is set to current, and this link is removed. Once it is done, Once this part is done, this part is done, we move the current pointers ahead. So the current now moves here at linked list 4 and next node moves to linked list 5. We go into the recursive call again. The stopping condition is still not met, so we move ahead. We put next of next node, which is n double n, to the next of current next node. So this point is moved, and now we reverse the linked list. So 5's link would now point to 4. This is reversing the linked list, and we move the current pointers ahead. So current moves ahead and n, capital N, moves ahead. So next node becomes here. This was essentially null. So now notice our condition was stopping condition if next node becomes null. Since next node has become null, we return current node. So we return the current pointer. Notice that why do we return the current pointer now? Because the linked list that we have right now is essentially the reverse linked list that we want. It is basically something like this. If I clean this up a bit, so the nodes are the same and in the same order, but their links are reversed. So this is what we have essentially. So that is why, and now this is the current pointer. So this is now the head of the new linked list, the reverse linked list, and this is what we return. So from here, from the stopping condition, current is returned. Once current is returned, since we have a return statement here as well, so this essentially returns the current to its parent function call, and so on and so forth until the main function call, where we have the head of the linked list, head of the new linked list, which is this. So I hope you understood this recursive approach and how can we come up with a recursive approach once we have come up with an iterative approach. I've also verified this try to explain it to you using the dry run for the recursive approach. I hope this video helps you understand this. I'll attach the link for this recursive approach as well in the description below to my GitHub repository. Please feel free to watch that video. I have also attached my social media links in the description below. Please feel free to check them out. Thank you for your time and have a nice day.